Good morning to all. Myself, Dr. Ravi Shankar Dubey, Associate Professor, MIT School of Applied Sciences, MIT University, Rajasthan. Today we are going to discuss a topic, Laplace transformation. Laplace transformation is quite useful for many branches of engineering and sciences. Okay. It's widely used. Reason is that it is useful to solving differential equations with boundary values without finding the general solution and the values of arbitrary constants. It is quite useful in many fields. As we have talked about the Laplace transformation, we have the general definition of Laplace transformation. In the Laplace transformation, we transform the function to one t domain to s domain. T stands for the time domain, s stands for the frequency domain. As you have seen the equation number A, we have given a basic definition of Laplace transformation. Capital L is the notation of Laplace. So if we having some function ft and we have taken a Laplace transformation, so we have written L of ft as shown in the LHS left hand side of the equation number A is equals to fs. That means your Laplace transform of some function ft, we have give some standard notation capital Fs. Okay, that means your t variable transform into s variable, and its definition says that limit is running from the integration 0 to infinity ft e की power minus st dt. So it is a general relation of some function with some integration. As we have talked about the inverse Laplace transformation, the definition is given in equation number B. As we have seen the equation number B, L inverse of f bar s, L inverse is a stand for inverse Laplace transformation. It will be shifted to ft and its value is depending on the contour integration, that is 1 upon 2 pi j sigma minus j infinity to sigma plus j infinity fs e की power ts ds. It is the definition of inverse Laplace transformation. Then, in generally, we do not use equation number B to take an inverse Laplace transformation. In general manner, we are not going to use it. Reason is what? It is depending on the contour integration. However, this is formally way of one would we take the inverse, but it is in a formal way. To use equation B requires the background in the use of complex variable and the theory of residue. Fortunately, we can accomplish some goal by using partial fraction expression. But thing is what? It being sometimes very quite typical to find out the inverse Laplace transformation. So there are some certain approaches. By following these approaches, we can find out the inverse Laplace transformation directly, not going through the residue approach. Okay. Residue approach will be have study in the complex analysis section. When we have studied the complex analysis, then we have discussed that how to find out the integration of contour. That will be studied in the complex analysis. Now, the thing is what? Few topics are to be very clear that application of Laplace transformation is one important thing is what? Laplace is useful for sectionally continuous function. Laplace can be found out of such function which are continuous in some certain domain. Okay, if they have a finite number of singularities, discontinuities, then we can also find out the Laplace transform of such functions. Now we talk about the initial value theorem. If we talk about the initial value theorem, if we having a function ft and its first derivative, the Laplace transformation of ft has the Laplace transformation noted by f bar s, fs, and then there exists limit n tending to infinity s fs. So as we have defined that limit s tending to infinity s fs should be equivalent to f of 0 as limit t tending to infinity ft. It is known as initial value theorem. The utility of the theorem lies in to take an inverse of Fs in order to find the initial condition in the time domain. This is actually using in circuit and systems. So as for the example, as we have go for the initial value theorem, we having a f bar s. The value of f bar s was s plus 2 upon s plus 1 whole square plus 5 square. Okay. Find f of 0 if the question is that one. Then the value of f0 is what? Limit s tending to infinity s fs. Okay. So when we have applied this limit s tending to infinity fs of this whole system, we have using a plus b whole square in the denominator of this equation, that s plus 1 whole square is what? S square plus 1 plus 2s. On simplification, we have reached to the conclusion of this solution. As our limit s tending to infinity, so I just take it s square common. So when we have taken s square common, numerator and denominator s square will be cancelled to each other. And on the simplification, we have found the value is what? 1. So that value, that f of 0 is equals to 1, we have concluded by this initial value theorem. Same the manner, we also having a final value theorem. What the final value theorem says that if a function ft and its derivative of Laplace transformation of ft use the Laplace transformation fs as limit s tending to infinity s fs exists, then this relation, whatever we have shown in the PPT, it should be exist. That means limit s tending to infinity s fs is equals to limit t tending to infinity ft is equals to f of infinity. This is known as final value theorem. Again, the utility of the theorem lies in having to take the inverse of fs. In order to find out the final value of ft in the domain, this is particularly useful in circuit and system. As for the examples, we have this is the example for final value theorem. If we having some f bar s, it is what? S plus 2 whole square minus 3 square upon s plus 2 whole square plus 3 square. We noted that f inverse of this function is equals to t e to power minus 2t into cos 3t. That's how to we find out this value will be discussed later on. Reason is that when we have talked about the Laplace and inverse Laplace transformation, then we have concluded this solution. Now, if we have question is will be that is this f infinity exists? Yeah, what is the value of f infinity? If we go by the final value theorem, the value of f infinity is what? Limit s tending to 0 s f bar s. Now put in the value of f bar s from the given as given in the question. We having limit s tending to infinity s of s plus 2 whole square minus 3 square upon s plus 2 whole square plus 3 square. While we take it something common from the numerator as well as denominator, as we have to put it s is equals to 0. So I don't think so it's being too typical. It is in the form of limit s tending to 0 fx into gx. So we have certainly separated these two limits, and when we have solved out them, we got it a 0 multiplied by some constant value then equivalent to 0. So the value of f infinity we have found it here 0. It was it is very essential to be discussed these things when we have to be defining the Laplace or inverse Laplace transformation of some function. Now we are moving and discuss that how to find out the Laplace transformation of some particular functions. As we have and by using the basic definition, and we find out the Laplace transformation of 1. That means your function is 1. As I have written here, ut is what your 1. As we have the basic definition, Laplace of ft, as you know that Laplace of ft is what? 0 to infinity e to power minus st ft dt. In this particular question, we having ft is equals to 1. So as we have put it here, your integration becomes 0 to infinity 1 multiplied by e to power minus st dt. While you integrating that, your integration becomes e to power minus st upon minus s with the limit 0 to infinity. As your upper limit is infinity, You know that infinity, e की power minus infinity is what? 0. So when you apply the upper limit, your answer becomes 0. And when you have applied the lower limit, your answer becomes e की power 0. And e की power 0 means 1. So while concluding that, your answer will be 1 by x. So what you have got is that your Laplace transformation of 1 is 1 by x. By the same the way, if you find out the Laplace transformation of t, you can, reason is that you just put it ft is equals to t, and on that basis you can find out the Laplace transformation of t, as well as the other relation can be also established. Now, if we have talk about the Laplace transformation of unit impulse function, it is very important for this, especially generally engineers are quite familiar with the unit impulse function. The important property of the impulse is a shifting property. Well, from the following, it is an important. If we having the limit t1 to t2 ft delta t minus t0 dt is equivalent to ft0 or 0, t1 is less than t0 is less than t2. This is the time domain where your function's value is ft0, and rest of the places, that means t is greater than t0 or t is less than t0, the value of the function is 0. While we have find out the Laplace transformation of unit impulse function, okay, on solving we get that Laplace of drag delta t is what? 0 to infinity delta t e की power minus st ft. While applying the certain limit, whatever we have given in the definition of drag delta function, simply you have find out the integration's value is e की power 0. E की power 0 means 1. So the Laplace transformation of drag delta function is 1. It is to be memorized in your mind. Laplace transformation of drag delta function is 1. It will be certainly asked in the questions of the gate, etc. It's a particular question. What is the inverse Laplace transformation of 1? Maybe it's asking on such a way. Go. Now, furthermore, and the important point to be remembered, that ft is converting to f bar s, then f bar s can be remapped into ft. The above statement, as we have write it here, the above statement that ft and fs are the transformation pairs. This means is that ft there are a unique fs. If some ft we having some particularly unique fs, it should be exist, and for each fs there should be a unique ft. We can remember the pair relationship between the approximately 10 Laplace transformation pairs, because it is quite useful for solving the Laplace transformations questions. If we have remember the particular question, Laplace transformation that are quite useful for solving our problems. Moving forward, out of these few ones are, as we have told you that a few should be memorized in your mind. Out of these, one function is e की power minus at. If we talking about the Laplace transformation of e की power minus at, then its value is equivalent to 0 to infinity e की power minus at into ft, and your ft is the Laplace transformation of ft, as we have earlier discussed. Laplace or transformation of ft is what? 0 to infinity e की power minus st ft dt. At that case, ft is equals to e की power minus at. We just put it here, and your limits will be becomes 0 to infinity e की power minus at into e की power minus st dt. As you know that when two functions whose base are same, their power will be added. So it becomes 0 to infinity e raised to the power minus s plus a into t dt. On solving the integration, you know that e की power at the integration has become e की power at upon t. So the constant value, that constant value is what here? Minus s plus a. That will becomes in the denominator, and while you applying the limit 0 to infinity, your upper value, that infinite, make e की power minus infinity is 0. And while you putting the lower limit 0, and it becomes e ki power 0 is 1. So on solving, your answer will be 1 upon s plus a. So what the pair is says that if your ut is what? E ki power minus at, then your Laplace transformation becomes 1 upon s plus a. While if we are going by the inverse Laplace transformation, so f inverse of 1 upon s plus a is remapped into e ki power minus at. So it should be have a formula for you that Laplace transformation of e ki power at is what? 1 upon s plus a. Okay, and L inverse of 1 upon s plus a is what? E ki power minus at. We have to be memorize both the things, Laplace as well as inverse Laplace transformation, because as I have discussed earlier, we are not going to use the contour integration, okay, to solving the inverse Laplace transformation. So these are the formulas we have make our results directly by using these relations. Okay, so if I have taken a simple question from the audience side, that if I have talked about what is the Laplace transformation of e ki power minus 2t, if we compare it from the e ki power minus at, the value of a is what? 2. So it is clear for this formula, the Laplace transformation of e ki power minus 2t is what? 1 upon s plus 2. Okay, and same the manner, if I ask that what is the Laplace transformation of 1 upon s plus 3? What is the inverse Laplace transformation of 1 upon s plus 3? Obviously, it becomes e ki power minus 3t. This is the way on which we can find out the question's solution. Now, same the manner, another important question is what? We have to find out the Laplace transformation of ft. If we have talked about the Laplace transformation of ft is equals to t, then by using the basic definition, as the basic definition says that Laplace transformation of ft is what? 0 to infinity e ki power minus st ft dt. At the certain time, I have the value of ft is equals to t. I just put it here. So it becomes 0 to infinity t e ki power minus st dt. As you are familiar with the formulas of u into v. So by using 0 to infinity uv, we got the certain values. I have considering that u is equals to t and dv is equals to e ki power minus st dt. Now using the u into v approach, we have solved the integration and find out the Laplace transformation of t is what? 1 by s square. Now moving forward, if we have moving forward, we have talked about the Laplace transformation of cos wt. Okay, we polynomial functions we have discussed, that is Laplace of t. Okay, same if we have go previously. So now we have talked about the Laplace transformation of cos wt. If we have talked about the definition of cos at, the value of cos at is equivalent to e ki power at, e ki power iat plus e ki power minus iat upon 2. Using that definition, I have put it this value into the basic definition of Laplace transformation. So Laplace transformation of cos wt becomes 0 to infinity cos wt e ki power minus st dt. Now I just put it the cos wt's value e ki power j wt plus e ki power minus j wt upon 2, where j is stand for under root of minus 1. On solving that, when we have multiplied these two brackets, you know that when base are same, the power will be added. So you have reached to your first value of the function 1 by 2 just comes outside of this integration, and the power of e becomes e ki power j omega minus st. If I just take it minus outside, so it becomes s minus j omega plus e ki power s plus j omega t. On simple integration, as I have done earlier, e ki power at is integration becomes e ki power at upon a. I just got it e ki power j minus s minus outside s minus j omega outside t, and same the manner minus outside j plus jw plus s into t. Okay, apply the limit infinity as well as 0. When you apply the limit, e ki power minus infinity becomes 0, as we have already discussed earlier. And when you put it 0, the e ki power 0 is 1. On solving that, you got it 1 by 2, 1 upon s minus jw minus 1 upon s plus jw. On take it LCM, you got it. In the denominator, you having a plus b, a minus b. You know that a plus b into a minus b becomes a square minus b square. But due to the j square, and j square is equivalent to minus 1, so it becomes s square plus omega square. And the numerator becomes twice s. 2 will be cancelled with the denominators 2. So your answer will be s upon s square plus omega square. So what we got it? We have got it, the Laplace transformation of cos wt is what? S upon s square plus w square. Same the manner, if I talk about the Laplace transformation of sin at, it becomes, as we have the definition of sin at, the value of sin at is equivalent to e ki power j at plus minus e ki power minus j t upon 2. So nothing 2i. So nothing more than that. It is quite simply used do by the same approach. And on solving that, your answer will be the Laplace transformation of sin at is becomes a upon s square plus a square. The same approach which we have used for this question is useful, applicable for that. Now, shifting approach, it is the good one. If the thing is what we have the particularly known some Laplace transformation of some function and some shifting will be there, then use this approach. So, what is there? Laplace of ft minus a multiplied by ut minus a. Ut minus a having two values. First value is 1, another value is 0. And 1 is defined for particularly when time domain t is greater than a, and 0 will be defined when t is less than a. So, if we have put it using this formula, your answer will be becomes as the limit will be vary from the Laplace transformation is running from 0 to infinity e ki power minus st ft dt. But while in this case, your limit will be in 0 to a, split it in two parts, 0 to a plus a to infinity. In 0 to a, your answer will be 0, so your limit will be remains only a to infinity, as you have seen in the first line of equation. So, Laplace of such function is equivalent to a to infinity f t minus a e ki power minus st. While we put it some certain variable equivalent to t minus a, that means considering x is equals to t minus a, differentiating on both sides, we got it at dx is equals to dt. While changing the limit, first you have put it t is equals to a, and then you put it t is equals to infinity, the limit will be changes from 0 to infinity. You have converted your whole integration, your integration becomes 0 to infinity f of x e ki power minus s, and when you put it the value of t, it becomes x plus a. I think so something is common from this integration. This integration having a respect of x, so the value of sa e ki power minus sa is in a constant, I just take it outside. So it becomes 0 to is equivalent to e ki power minus sa outside, 0 to infinity fx e ki power minus sx dx. The integration is definite integral having the basic definition of Laplace transformation. So it becomes Laplace of ft, yeah, f bar s. So your answer becomes e ki power minus as f bar s. So it's quite useful for many places. Now, same the manner, if I go particularly for frequency shift, that means we got it a multiplication of Laplace function with e ki power minus at. So your answer becomes, as we have written in the last line, Laplace of e ki power minus at ft is what? F bar, yeah, f s plus a. So how to solve this approach? Simple. We have using the basic definition of Laplace, that is 0 to infinity e ki power minus st ft dt. But at the certain time, we having ft is equals to e ki power minus at into ft. I just put it back here. And while the base are same, power will be added as we have earlier discussed. So the power of E becomes minus outside S plus A into T. So if we go for the basic definition of Laplace, we know that Fs is equals to 0 to infinity e की power minus st ft dt. But at the second line of this slide, we have seen that at the place of s, we having s plus a. So it will be equivalent to f s plus a. It is widely used. Reason is that when we have a Laplace transformation of some function, ft is equivalent to f bar s. That means you have know the formula that what is the value of Laplace of ft. Then if that ft is multiplied by some exponential function e की power minus at, then nothing to be worried for that. Reason is that whatever the answer we have for ft, simple what happened, we having a frequency shift. Yani where you got it as, you just put it as plus a. So you can easily find out the solution of many questions. Now moving forward, the shifting applications is shown here in this next slide. If we have to find out the Laplace transformation of e की power minus at cos wt. Okay, so we have in the previous slide e की power at ft. So considering that ft is equals to what? Cos wt. Before that, I have talked about the Laplace transformation of cos wt. So I have already memorized the answer that Laplace transformation of cos wt is equivalent to s upon s square plus w square. Now, using the previous theorem, what it says that if we having to find out the f of some function which is a multiplication of e की power minus at, your answer will be Laplace of e की power minus at ft is equals to f s plus a. So what happens here? We having s plus a. That means you have simply replaced s by s plus a. So you have seen that numerator we having s, so it becomes s plus a. Okay. Same manner, denominator we having s square, so it becomes s plus a whole square. So your final answer will be easily concluded. So what is the Laplace transformation of e की power minus at cos wt is what? S plus a upon s plus a whole square plus omega square. Now moving after that, we having a multiple number of theorems for the Laplace transformation. As we have already discussed that few Laplace to be memorized, as well as we have to memorize the few theorems as well. If we talk about the integration, time integration property, it says that Laplace of 0 to infinity ft dt is equivalent to f bar s upon s. How to prove this theorem? As you know that the basic definition of Laplace of ft is what? 0 to infinity e की power minus st ft dt. As you know that here the ft's value is what? 0 to infinity ft dt. So I just put it this in the definition of Laplace transformation. So you have reached to your first line of the expression. Now you know that the formula of u into v, integration by parts. Okay, u into v. So if we have considering u is equals to 0 to t fx dx, and on that basis what you got it from the du, simply differentiating on both sides using a Leibniz theorem. So du is equals to ft. On solving that, we have reached one more thing considerable, that is dB is equals to e की power minus st dt. On integration that, we got v is equals to what? E की power minus st upon minus s comes into the denominator. So we have already decided what is the value of u and what is the value of v. Now applying the integration by part, we have got it. The first integration value, when you have solved them and apply the limit infinity and 0, infinity, your answer will be 0. When you put it 0, the answer will be 0 in the first integration, first part of the u into v approach. And the second will be this one, 1 upon s, 0 to infinity e की power minus st ft dt. As you have seen that 0 to infinity e की power minus st ft dt, it is a basic definition of Laplace transformation of ft and whose value is equal to fs. So the answer becomes f bar fs upon s. So it becomes a key for us when we have some questions having a Laplace transformation from 0 to infinity ft dt, then its answer will be fs upon s. Okay. Now moving forward, this is the one of the key which we have to be keep in our mind. Now the second thing is what is the Laplace transformation of derivative of the function? Previously we have discussed the Laplace transformation of integration of some function. Now we talk about the derivative of some function. Their applications will also be discussed, but it will be discussed later on. Few questions will be also discussed on this basis. Now, so what is the theorem statement of this theorem says that if we having Laplace of ft is equals to f bar s, then Laplace of d over dt ft, yeah, we can say that Laplace of f dash t is equivalent to fs minus f of g. Remember that as you have said that I have used this capital F as well as the small f in the notation. So small f is a function when your time domain is given, and capital F is a function when it is defining in S domain or frequency domain. So it's quite useful for us. How to solve that? Again we go for the basic definition. What the basic definition says that Laplace of ft is equals to 0 to infinity e की power minus st ft dt. But at the moment, what is the ft? It is already a derivative, f dash t. So just put it in the formula. So it becomes 0 to infinity. Yeah, Laplace of f dash t is equals to 0 to infinity e की power minus st f dash t dt. Now to solving this, we have considering u is equals to e की power minus st and dv is equals to dft upon. On solving that, your du becomes minus s e की power minus st dt, and on solving that, v is equals to ft. While you put it in the formula u into v, you know that what is the formula of u into v? Integration u into v, u as it is, integration of v minus integration derivative of u, integration of v dv. So while you have put it all these values here, you have reached to that formula. Okay. So while you are applying the limit, your first limit, when you apply the limit in the ft e की power minus st, when your upper limit is infinity in the first equation, so e की power minus infinity becomes 0, your function becomes 0. When you put it 0, e की power 0 is 1, and f of 0 we cannot say about the f of 0, because if your function is sin t, so sin 0 becomes 0, and if your function is cos t, cos 0 becomes 1. So we cannot say that what is the value of ft. So I just put it f of 0 minus 0 to infinity ft, and while we have differentiating take it a differentiation of e की power minus st, it becomes e की power minus st, and again we differentiating with respect to t, you got it a multiplication of minus s. On solving, you got these to the second equation. On properly you have seen that the second equation having the integration, and what is the integration says that its value is 0 to infinity e की power minus st ft dt. Again L of ft, yeah, f bar s. So it becomes final conclusion that Laplace of d over dt of ft is equals to f bar s minus f of 0. This can be generalized. Generalized in that sense, we have taken a second derivative, we have the third derivative, we have another derivative, whatever is given in the question. As we have already told earlier, Laplace having a wide application in the field of solving a differential equation. So these are the keys which are very much useful for us. As I told earlier, in the Laplace transformation, we have a strength to convert the differential equation into the polynomial equation. As we have seen the last equation, your derivative is converted into a polynomial equation, and polynomial equation is quite easy to the analysis. So if same the manner, if we have to find out the Laplace transformation of double derivative d2f upon dt square, then same the manner you have applied the approaches. Okay, and when you have similarly applied the approaches, what you have find out, your answer will be what? Minus of f of 0, f dash of 0, plus s of Laplace of f dash t. And if you put it the answer from the obtained result, your answer will be s square f bar s minus s of f0 minus f dash of 0. I think so. This will be discussed in the next slide. Okay. Here you have the relations that Laplace of double derivative d2f upon dt square is equal to s square f bar f minus s of f of 0 minus f dash of 0. Same the manner, if we go for the third derivative, your answer becomes s cube f bar f minus s square f0 minus s f dash 0 minus f double dash 0. And in general, optimizing the general relation, we have reached to the nth derivative. It becomes s की power n f bar f minus s की n minus 1 f0 minus s n minus 2 f dash 0 and dot dot dot. At last we having f n minus 1 of 0. So it is in a basic formula which we have going to be used. Okay, this is the table which you should be memorized, that what is the Laplace transformation of drag delta function is equals to 1, which we have already proved earlier. Same the manner, Laplace transformation of ut is what 1 upon s when u is a unit step function, and Laplace transformation of e की power minus st, which we have already proved that 1 upon s plus a Laplace of t 1 by s square. On that basis of t 1 t square, we have a general relation that Laplace of t की power n is equals to factorial n upon s की power n plus 1. Same the manner, if we have moving the other relation like Laplace of t e की power minus at, it becomes 1 upon s plus a whole square. If you have want to prove this relation, simple approach you can use that if we having the Laplace transformation of t, Laplace transformation of t is what 1 by s square, and the theorem, shifting theorem, as we have discussed earlier, when e की power at, e की power minus at comes with the multiplication of ft, it becomes 1 upon s, it becomes f s plus a. Okay, so thing is what, your functions Laplace of t is what 1 by s square, and you have shifting approach, it becomes for the Laplace transformation of t e की power minus at is become 1 upon s plus 1 whole square. Same the manner, Laplace of t की power n is what factorial n upon s plus s की power n plus 1. When you using the shifting approach, Laplace of t की power n e की power minus at, it becomes factorial n, and your s will be replaced by s plus a, it becomes s plus a raised to the power n plus 1. Same the manner, we have also discussed the Laplace transformation of sine omega t, yeah, wt is equals to w upon s square plus w square. Same the manner, cos wt is equivalent to s upon s square plus w square. Okay, and while the shifting will be also included with this, yani e will be come in the multiplication of sine, so we have to find out the Laplace transformation of e की power minus at sine wt. As we have already discussed, Laplace of sine wt is equivalent to w upon s square plus w square. So while e की power minus at is multiplied with this sine wt, it becomes replaced as by s plus a. So it becomes w upon s plus a whole square plus w square. On the same way, you can find out the Laplace transformation of e की power minus at cos w. So your answer become as the cos Laplace transformation is s upon s square plus w square. So the answer when e की power minus at multiplied by cos wt, it becomes s plus a whole square plus w square. Same the manner, sin wt plus theta can be also evaluated. It can be also evaluated by using the approach of the formula of sin theta, sin a plus b. Sin a plus b is what? Sin a cos b plus cos a sin b. So if you want to separate them, you have separately solved them and put it the value of sin omega t, sin Laplace transformation of sin wt, and sin cos theta as being constant. Same the manner, next time sin theta becomes a constant, and we have to find out the Laplace transformation of cos wt. So it's an easy way to find out the Laplace transformation of this function. Same the manner, the next answer can be also concluded that Laplace transformation of cos wt plus theta. These are the few relations which we have to be memorized to determining the result. These are the formulas for their respective theorems, which we have already discussed earlier, that what is the Laplace transformation of TFT. Okay, that theorem will be also discussed later on. It is equivalent to minus d over ds f bar s. And Laplace transformation of d ki power n ft t ki power n is equivalent to nth derivative Laplace you have already discussed, s ki power n f bar s minus s n minus 1 f of 0 minus s n minus 2 f dash 0 and dot 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 so on f n minus 1 f of 0. All these things we have read it earlier. These relations should be memorized and keep in your mind. Reason is that when you have solved the problems, these are very much useful for solving the problems. Now, Mathematica is quite useful for us as well. Reason is that today is the world of global scenario, so the software is quite useful for us. So you can also determine the results by using the software approach. If we go by the MATLAB software, you can also find out the Laplace transformation of t e ki power minus 4t. If we go by the approach of simple mathematical calculation, we can use the shifting approach. As you know that Laplace of t is what? 1 by s square. Then by shifting, Laplace of t e ki power minus 4t is become 1 upon s plus 4 whole square. So answer will be in front of us, but the programming is give us the strength for solving the many problems. So if we go for the MATLAB, we can also find out the solution. This is the program how which we have used the command window and find out the Laplace transformation of t e ki power minus 4t. Okay, but remember that the programming, whatever the symbols we are going to use, that are properly written. While if you have not properly writing the statement of the problem, then always error will be occurred and you cannot conclude your answer by using this certain software. Okay, so how to write it the Laplace of some function? We have written Laplace system of t and f, means t is transformed into as Laplace t star. The t function is being multiplied with the exponential function t star e exponential of minus 4 into t, because two variables are being multiplied, so we have using star notation between them. Then t is converting into s, and while you have putting that, your output answer is what? 1 upon s plus 4 whole square. So this is the way, on that basis we can find out the Laplace transformation of some function using MATLAB. I have used one more expression for doing the inverse Laplace transformation of some function. Okay, we have a function fs is equals to s upon s, fs is equals to s multiplied by s plus 6 upon s plus 3 s square plus 6x plus 18. If we go to find out the inverse Laplace transformation, it is being a lengthy question. Reason is that first of all we have to using partial fraction and separate these particular function of s and separate them. That means we have considering that a upon s plus 3 plus bs plus c upon s square plus 6s plus 18. And while doing this, you have make it a relation and find out the value of constant a, constant b, constant c. Just put it them back, and while doing the calculation of taking an inverse Laplace transformation, you know that the inverse Laplace transformation of 1 upon s plus a is what? E ki power minus t. So minus 80. So we have using this relation, you have find out the inverse Laplace transformation of that our function. While if we go by the MATLAB approach, its system will be quite easy. Reason is that you have written system st. Now you have transposing your s domain to t domain. In the previous question we have transforming t to s. Okay, so system st. Previously we have written system t to s, and your notation becomes, last time it is only Laplace, now I write it I Laplace. I means inverse Laplace of your function. First function in numerator having s multiplied by s plus 6. So s star s plus 6 upon, again in the scene in the denominator, s plus 3 multiplied by the next bracket. So it becomes s plus 3 star s square next plus 6 and s will be multiplied. So 6 star s plus 18. Okay. Those brackets we are opening, just close them. All these should be closes. And when we have go for the output of this relation, your answer will be that. So things are very easy when we are go by the software approach. So programming is also useful for us. So these are the few relations or few topics we have discussed here. Things is what Laplace having a multiple use in many dimensions. So that is a very important topic for all the engineers and students of science and engineering. It is very useful for solving differential equation, as I told earlier. So it should be a strengthful subject for you. It gives you a strength, and programming gives a time saving approach. So you also go for the programming. Next topic of these topics will be discussed later on. Thank you.